Just a few days ago, as all of us probably know by now, Rocket Lab managed to carry out a mission that SpaceX simply could not accomplish, and this was to deliver a NASA probe, or a NASA satellite rather, all the way to cislunar space for a fraction of the cost of what it would have taken to get a Falcon 9 to do the same job. And this begs the question, just how big of a need is there for these kinds of launchers, not only in terms of missions for NASA, but for the ESA, the Japanese Space Agency, private universities, just about anybody who wants to send out a more modest sort of probe or satellite with rather limited capabilities compared to the massive kinds of probes that NASA has been accustomed to in the past, but can still get the job done and for a lot less money. Because let's face it, if it's a dedicated mission, Falcon 9 just can't do it for less than $55 or $60 million, whereas Rocket Lab can do it for about 10. And even though Starship is on the cusp of offering 100 metric tons all the way to low Earth orbit for a low price, the whole notion that they're going to be able to do it for $2 million is deeply flawed. If SpaceX started doing that right off the bat, they would never recoup the massive amounts of investment they've had to make in Starbase and development, everything else that they've had to do to build Starship, which has required billions of dollars. You're not going to recover billions of dollars of investment $2 million at a time. It's simply not realistic. At best, Starship is going to be launching its payloads for maybe $100 million a flight, which is ridiculously inexpensive. But once again, if it's a dedicated mission, it's not competitive with these kinds of launchers. And various types of satellites, probes, and other missions are going to have to be dedicated. Lots of them don't need to go to low Earth orbit. They need to go to sun-synchronous orbit, or they need to go to geostationary orbit, or they're going to Mars, or perhaps even Pluto, which means small sat launchers like Electron are going to be very much in demand. And the Europeans have recognized this. So here's a list of 10 of the most promising small sat launchers that are going to be hitting the market in the next few years, including, as you can see right here, the idea of launching a rocket from a balloon. Strap yourselves in for a whole new world of innovation. And now that I've got your attention, here's the High Impulse SL-1 from Germany. There's nothing particularly fancy about this rocket. They're looking for reliability using technology that's proven, but at an extremely low cost. The rocket engine that you just saw being tested there is capable of 75 kilonewtons, so the entire operation, obviously, is to put several of these engines on the first stage to deliver the maximum thrust. In this case, 8 of these engines to deliver 600 kilonewtons. Now, by way of comparison, the Rocket Lab Electron is only capable of generating a peak thrust of 224 kilonewtons. So we're looking at a significant increase in thrust and therefore of payload. In addition to that, it also has turbo pumps built in, which deliver 47 kilograms per second of liquid oxygen, utilizing 3D printed components, by the way. And then after that, it has a cluster of 4 more engines that deliver another 400 kilonewtons worth of thrust. That's actually a hell of a lot for a second stage on a small launcher. And then the third stage will have 4 engines delivering 25 kilonewtons apiece, so another 100 kilonewtons on the third stage. This will deliver a minimum of 500 kilograms up to low Earth orbit, or nearly double that of the Electron, and personally I think they might be able to accomplish more than that. However, it's utilizing very traditional types of fuel, liquid oxygen, and something that they sort of euphemistically call paraffin, but it's actually just kerosene, so it's the type of fuel that's going to generate greenhouse gases and therefore may not be quite as popular in certain parts of Europe. However, they've already received at least 10 million euros worth of funding, and what you've been looking at for the most part is a suborbital proof of concept rocket before they head to orbit. But let's move on to another rocket that's using an entirely different and innovative type of propulsion, the NVOL, which is an international consortium led by Norway. Now, this doesn't have nearly the capability of the high impulse rocket, only about 200 kilograms up to 600 kilometers, that is to say, a sun synchronous orbit, which is going to be extremely important for small sats in the future, simply because they need to have their solar panels constantly exposed to the sun. That makes them far more efficient. Now, there aren't going to be a lot of rockets heading to SSO, so NVOL is an interesting concept, but the most important thing about it is it runs off of hydrogen peroxide as an oxidizer and HTPB for fuel. That's a new type of hybrid engine that produces very little in the way of greenhouse gases and should be extremely attractive to any European customers in the future. And I love this picture of NVOL flying against the northern lights. Again, this will be a launcher that can access sun synchronous orbit and polar orbits very easily, simply because it's being launched from Norway. Now let's move on. As I've mentioned before, people often wonder why I'm so interested in United Kingdom spaceflight. Well, it's simply because there's so much innovative work going on there, and this is a rocket that I have never mentioned before. It's called the Colibri from B2 Space. It doesn't have a particularly tremendous payload, only about 200 kilograms up to SSO, but here's the amazing thing, as I'm sure you can probably tell at this point, you launch it from a weather balloon, carry it up to extremely high altitudes, far higher than any horizontal launch provider could possibly manage, and launch it from there. What that means is a tiny rocket, and by the way, this is the smallest rocket that I'm going to discuss in this video, is still capable of delivering 200 kilograms up to SSO. That means you're going to be able to deliver a dedicated mission up there for a very low price, perhaps as low as a couple of $1 million. And it is for this reason that they've received 4.2 million euros worth of funding thus far. That may not sound like a hell of a lot, but any rocket company or launch provider, any of these new emerging companies, are very lucky indeed to receive any funding whatsoever. And the last 3 that I've discussed are indeed receiving funding. And incidentally, I'm going to be personally visiting several UK launch providers while I'm making my journey over there in September. So thank you so much to those of you who have supported my channel because you've made this possible. And for those of you who are still interested in supporting this trip over to the United Kingdom, please check out the description. There are many ways to keep this content coming and to continue covering launch providers and spaceflight innovation that very few channels are covering right now. And speaking of innovation, and speaking of companies that have a lot of financial support, I must extend my formal apologies to the Spanish because they have a company that's received a tremendous amount of funding and are planning to send up perhaps the best of all of these small-sat launchers called the Mura 5. Now, this is a rocket that's going to be capable of reuse on its first stage, which is very cool. That's a good thing to start off with. In addition to that, it's going to have a hell of a lot of thrust. We're talking about 525 kilonewtons at sea level being delivered by only 5 engines, so 105 kilonewtons per engine. Once again, that's nothing compared to Raptors, but it's pretty damn powerful for a small-sat launcher, far more powerful than the Rocket Lab Rutherford. The second stage will have one engine delivering 45 kilonewtons worth of thrust in vacuum. It will also have a kick stage available, allowing it to propel payloads to even higher orbits. We're talking 450 kilograms up to Sun synchronous orbit, which is substantially more than Rocket Lab, giving this company the capability of delivering these standalone space missions all the way out, perhaps even to the planets, for a much, much lower cost. Now, I'm not saying that Rocket Lab is inferior or Rocket Lab is not going to be able to compete. They're actually in orbit and delivering these missions right now, whereas these companies certainly are not, so they've got a lot of catching up to do, and in the meantime, Rocket Lab is coming out with Neutron, which is going to put them in a whole different dimension of competition. But if we want to talk about a rocket that can deliver a minimal amount of payload up to orbit for a minimal cost, I'm talking $1 million per launch. Yeah, only 100 kilograms, but still $1 million per launch. Well, you gotta go to Cardiff, Wales, where they're doing this. Okay, granted, that's just a Pathfinder engine, but the long-term goals of the company called Small Spark, which in my opinion they are aptly named given everything we've been looking at thus far, is pretty cool. Once again, 100 kilograms up to orbit for $1 million, which means if you have a dedicated mission and your satellite weighs less than 100 kilograms, which is entirely possible, you can do that mission for $1 million. There are plenty of academic institutions and other small companies on the planet that would be capable of handling this. And this, by the way, is an upgraded version of the rocket with several engines capable of 400 kilograms up to orbit, although I'm not sure where they are with their development on this up to this point. I'm going to be finding out soon, though, because apparently I have a conversation scheduled with their CEO tomorrow. I'm very excited about that. But another thing that encourages me about this company is their Frost micro rocket that's only suborbital but is recoverable. So they're looking at reusability even with their orbital rocket. This is something that obviously I like in any launch provider, especially somebody that's only looking at sending up tiny payloads. It's very unusual for these kinds of companies to be pursuing reusability. But if you want to talk about a unique and interesting way of handling reusability, well, I won't say unique because we've already looked at it. We're talking about going up to the stratosphere in a weather balloon and launching from there, just a little bit differently this time, with a vehicle called Blue Star being developed developed by a company called 0 to Infinity, once again in Spain. And again, I apologize to all of my Spanish viewers. You guys are doing fantastic stuff. Not only is this company talking about deploying up to 140 kilograms to sun-synchronous orbit using a single-stage vehicle launched from a balloon, but they're also talking about, well, near-space tourism at 20,000 meters in essentially what amounts to a floating bar or a floating space tourism experience way up in the stratosphere, double the height that is achieved by a commercial airliner. An amazing thing to experience, no doubt, and once again, extremely innovative and coming out of Europe. I am very excited to see which of these concepts succeed and which of them fall into disuse. Personally, I hope all of them succeed, and fortunately, 0 to Infinity has also received millions of euros worth of investment. And I know you're sick of hearing about these guys, but I can't discuss European launch providers without including Scotland in the mix. And the Skyrora XL is one of the most impressive of the lot. The first stage of this innovative rocket is propelled by 9 Skyforce engines with a thrust of 630 kilonewtons at sea level. Once again, keep in mind that Rocket Lab has a peak performance of just over 220 kilonewtons. Stage 2 is propelled by 1 Skyforce engine with 85 kilonewtons, and finally their Space Tug that I've talked about many times has an LEO engine with only 3.5 kilonewtons worth of thrust with an ISP of 305 seconds. However, it can be ignited multiple times for multiple secondary missions in orbit after the primary mission is completed. This is going to allow the Skyrora XL to carry out a variety of tasks in orbit that virtually no other rocket can. After completing its primary mission, it can deorbit space junk or perhaps perform maintenance on a malfunctioning satellite. So many different things that this innovative rocket is capable of carrying out. Plus, it's powered by Ecosene, which runs off of waste plastic, something we need to get rid of anyway. I can't wait to tour these guys' facilities in Edinburgh, Scotland when I make my visit in September, and once again, that's all because of your support. Now, there's a ton of other UK space launch providers that I haven't discussed. Black Arrow, Orbex, quite a few others. If you're interested in checking that out, once again, for the millionth time, here's my latest video on British spaceflight. Click on this if you want to check this out. Plus, I have some unique merchandise specifically associated with British spaceflight. Okay, let's move on to the French, and I'm not talking about Arianespace, I'm talking about something incredibly cool. Sirius Space Services, unlike Arianespace, are embracing reusability right off the bat. They're only looking at 2 stages per booster, one of which is a kick stage. The launcher height is only 23.5 meters, but there is a lot of thrust being generated by their Star 1 engines, 342 kilonewtons, with 38 kilonewtons being delivered by the kick stage. And after that, you have the Sirius 13, which has 3 of these boosters, and that pushes up its capabilities tremendously to 1,026 kilonewtons. And after that, you have the Sirius 15, which has 4 boosters on it, and that has 1,710 kilonewtons, which is miles beyond everything I've talked about up to this point. The Star 1 engine makes use of liquid oxygen and liquid methane for maximum performance, allowing the Sirius 1 to carry 175 kilograms to sun-synchronous orbit, the Sirius 13 500 kilograms to sun-synchronous orbit, and the Sirius 15 800 kilograms to sun-synchronous orbit. We're talking quadruple the capability of the Rocket Lab Electron, plus full reusability. But if we're talking about launch providers who are within 12 months of launch, and I've talked about a couple of them so far, but somebody who's really capable of sending up massive amounts of payload for a minimal cost, you got to go to Germany for the last two launch providers, and the first of these is Rocket Factory Augsburg. We're talking about an unbelievable payload capability, and by the way, I interviewed these guys about a year ago, and I have that interview linked in the description. It was very, very interesting, but what's impressive about all of this is they're making use of the same kind of staged combustion technology that's used in the Raptor with the same kind of fuel. In many ways, this is a hybrid rocket between the Falcon 9 and the Electron. 9 engines in the first stage, 1 engine in the second stage, plus a kick stage, allowing it to push 1,600 kilograms to LEO, 1,350 kilograms to a polar orbit, 1,200 kilograms to Sun synchronous orbit, 650 kilograms to a 2,000 kilometer orbit, and finally 450 kilograms to a geosynchronous transfer orbit. Therefore, this rocket is theoretically capable of pushing approximately 400 kilograms to another planet, which is far more than any other small sat launcher is capable of doing. Nothing comes anywhere close, except perhaps for the next rocket on our list, number 1, also from Germany. And please keep in mind that these launch providers are in no particular order. They're all doing special stuff, but Isar Aerospace, in my opinion, is one of the most promising. They've received over 160 million euros worth of funding. They have 189 employees, and their rocket is all built in-house. 3D printed engines, 3D printed parts. Something very different from Rocket Factory Augsburg, who are making use of a lot of off-the-shelf products in order to keep costs down. I'm not sure which philosophy is going to work better, but Isar Aerospace is looking very promising. A full metric ton all the way out to low Earth orbit. And keep in mind, that's more than triple the capability of the Rocket Lab Electron. Once again, not talking down about Electron, they are really well established. Rocket Lab is facing a very bright future, but nevertheless, these guys are accomplishing impressive stuff and are going to be strong competitors, not only for small sats, but also the capability of launching up pretty sizable conventional satellites for a very low price, utilizing the same kind of propellant and the same kind of in-house manufacturing philosophy that both Rocket Lab and SpaceX make use of. And also something that I'm very excited about is the fact that this company is collaborating with a company called D-Orbit, and I bet you can guess what that's all about. Cleaning up LEO, yet another company in Europe that's engaging this particularly dangerous situation that's developing in orbit that could sabotage our future as we expand into the solar system. So that's it. 10 really exciting cutting-edge rockets to compete with SpaceX, at least as far as small sats are concerned. If you like what I have to do, please subscribe. Please hit that like and check out the description for ways to support my channel. And until everybody recognizes that innovation in spaceflight is not something that's restricted to my side of the Atlantic, I urge all of you to stay angry about space.